So these are the three words we're going to talk about today. Prisms, dispersions, and deviation. And I get really easily confused between dispersion and deviation. So I want you guys to pay attention to these two words. And I'm going to define them in English and also then in the future define them in physics. Okay, so let's start at the beginning. We know speed equals distance over time. For a particle. We also know speed equals lambda f for a wave, where lambda is the wavelength and f is the, good. So this is wavelength and this is frequency. So I can say that sinusoidal waves with high frequency and short wavelength will travel with smaller speeds. Whereas waves with low frequency and long wavelength will travel with faster speeds. What does that mean in terms of when things go from one medium to another medium? So I'm going to draw a couple of boxes. So remember we were talking about optical path length, and when we talked about how path length changes depending on whether you're the viewer or you are sitting on the wave. Do you remember having that conversation? So now instead of having just one light that does that, we will have multiple lights. So light, white light, is composed of how many colors? 7 colors of the rainbow, starting from red and ending at blue, purple, blue, violet, right? So the colors of the rainbow, white light is made up of all of these colors, correct? Yeah. Red has the longest wavelength. Whereas violet has the shortest wavelength. So suppose I have a red light and a blue light. Is red longer wavelength or blue longer? Red, right? So I'm going to compare red to blue and see what happens. So if I draw a box and I have a red light coming in and a blue light coming in, red light will travel further in this medium than blue light. So that is for our plane plate. For normal incidence, that means hitting straight on a plane surface, I can say for red light, velocity or speed is higher, refractive index is lower, and lambda is larger. So lambda is really large. For blue light, speed is lower, refractive index is higher, and lambda is smaller. In other words, n, the refractive index, is actually a function of the wavelength. So the n that a light observes when it goes from one medium to another depends on the wavelength of light. And how do I write that in physics? Which is a very profound statement for me to make. So the refractive index that a light sees depends on its color. So a red light going through water will observe a different refractive index than a blue light, than an orange light. And which light will go the furthest out of all the rainbow colors? Red. Why do you think all of the caution signs are made with red? In through all necessary mediums. So let's say it's snowing, or it's raining, or it's a clear sky, or whatever is going on. Which light will travel the furthest? Hence, the red lights are all made for caution. Anytime you want to warn people, right? And now it makes sense. Okay, so now what happens if I have the same kind of situation, but instead of being head on, but instead I have a light that is composed of all colors, but at an angle. In that case, light will actually split into its component colors. So imagine I'm only talking about red and blue, right? So, but all the colors of the rainbow exist in there. And then red will be, Snell's law says it'll be diffracted, right? And then this will also be diffracted. So we will have red and blue. So when light is incident at an angle, the actual effect of n as a function of lambda will be to split the light into its component colors. Because each light travels a little bit differently through the medium because it experiences a different refractive index. So it actually splits into its component colors. And that effect is called dispersion. Okay, I'm going to write this down. Do we understand that? Same mirror, but the angle of incidence has changed. And now we are left with dispersion of light. Light incident at an angle. In this case, what will happen? Light will be separated into component colors, depending on lambda. However, outgoing rays will still remain parallel to each other. So the effect of me saying n as a function of lambda, refractive index depends on lambda, is that the light will be split into their component colors. Okay, now, if on the other hand, I have a shape like this, what happens in this case? So this is not a plain plate, but in fact, this is now a prism. what happens in this case? So a light coming in, originally, if it was going to go this way, this is now going to be split into component colors. Let's make a little bit of an angle. This will additionally deviate from its original path. So it will not only disperse into the component colors, but it also deviates away from its original path. So it'll be red and blue. And usually the way we do dispersion is we will look at the middle line, and that's how much it has deviated. And we call it delta. So the effect of converting light into its component colors is called dispersion. And the fact that it deviates from its original direction is called deviation. Okay, so now let's define the two terms. So for prisms, I want you to think about these two terms: deviation and dispersion. So deviation is how much the light deviated from its original path. You measure it through the center of the deviation. Okay? Dispersion is how much the light split into its component. Like what's the angle of the fact that the light split between red and blue?